The first slide is it's about cryptocurrencies and blockchains. It's really hard for me to see up here on the stage in lights, but can I get a show of hands of who has heard of Bitcoin? Okay, who has heard of blockchains? All right, little less. How about Zcash? One. Okay, one. Monero. All right, awesome. I'm going to blow your mind here. All right, so the whole theme of WSO2Con has been about digital transformations. We've heard governments try to move to cloud, analytics, the whole digital transformation. And I'm here this afternoon as your speaker after lunch, as one of your only woman keynote speakers, and the last ones. I think I'm the token woman here to talk about digital transformations in cryptocurrencies and blockchains. So I'm CEO, co-founder of BlockCypher. BlockCypher has been around for about 3 years. We are a startup. What we like to say is we are like Amazon Web Services for blockchains. We're an API company, so the application to everything. And we make it easy for companies to build blockchain applications. I am a former US Naval officer. I graduated from Stanford, the US Naval Academy. My background is aerospace engineering. And so this afternoon, I'm going to talk to you about a little bit the history of money, because you have to put that in context to see where we came from, to see where we're going to go. What is a blockchain? What's the difference between a blockchain and a cryptocurrency? I'll tell you a little bit about what we do at BlockCypher and also where I think blockchains are going to go in the future. The history of money. So money has been around for a very long time. There are useful commodities that have been traded at barter, such as cows, grain. Okay, those are useful things. You can eat them. There's also been things that are attractive, like beads and shells that have been used as a form of currency. Precious metals, gold, silver, jewels as well, and things called tally sticks, because it's very difficult to move very large quantities of grains, for example. Sometimes you have a tally stick, which marks how much you have, for example, in a silo or some other form of store. What we know as our currency right now is a banknote. A banknote actually started, so paper money first started in the Song Dynasty in the 11th century. That was your first form of paper note. And the banknote in of itself, which is more of a promissory note, actually came into being around the time of the 13th century, when explorers like Marco Polo found that it was somewhat impractical to carry very large sums of money. It was also very dangerous because of the many pirates at sea. And so that's when banknotes started to become popular in Europe. All right? In the US, our form of banknotes actually used to get issued by individual banks. And they were notes which were backed, supposedly, by a certain amount of gold and silver. And each individual bank, so there's actually about 5,000 banknotes. Only in 1913, so a little over 100 years, has our currency, has the Federal Reserve come into being, and what they wanted to do is create uniformity amongst all of those banknotes. So you can see that there has been actually a long history of money. So what I'm going to talk about now is what are the characteristics that have developed that make money a currency and where it's going to go to next. So when you look at what are 6 key characteristics of money in which you can buy goods and pay for things and pay off debts, it has to be divisible, okay? You can't just give one chunk of gold and say, this is what I want to purchase with it. It has to be divisible so you can purchase various quantities of things in exchange, okay? It has to be transportable, in which that I can walk around and I can pay for various things by having that money. There must be a limited supply so that there is actually a value that's being held within that money and that currency. There has to be fungibility. Fungibility is at $1, regardless of whether I have a coin or a dollar bill, they are equivalent in value. And it can be used in exchange. Durability, so certainly, like our banknote, we think of it as a paper note, but it's actually not. It's much more, it's closer to a cloth. It's a linen than a paper because it's not meant to be destroyed. It has to be durable in order to act as a form of payment or a store of good. And lastly, even though we have used barter systems, we still do, money is not designed to be eaten. And my kids, actually, so I have two younger kids, you know those little money things that are wrapped in foil? So the first year they got those, wow, they were so thrilled. And they used it as an exchange amongst their friends for various things that they would trade. And they would stockpile them. And I kept telling them, you know, the chocolate's not good to begin with. It's going to become even worse with time. It's really not a good stockpile. But they didn't believe me, right? They had these hordes of this foil-wrapped chocolate money. And then one morning, the dog ate all of the chocolate, and so they discovered the hard way that it was not a good form of money to have a consumable type of money. Okay, so as we look through the evolution of money, you can see that failure in each form has actually been an opportunity. So when you find out that money shouldn't be able to be consumed, then in barter systems, what's wrong with barter systems is that you have to have a coincidence of wants. If I'm a grain farmer and I want to trade it for a fruit that I want, then those two farmers, if they don't have their crops come to fruition at the exact same time, that it introduces a third-party commodity or a third-party currency in order to record when that wheat farmer, what the equivalent is that wheat farmer is, who's going to trade with that fruit farmer, all right? So you can see there's a little bit of mismatch there, and barter systems don't work that well because it is consumable and it is destroyed. When you look at our banking system, so when the Federal Reserve issued their universal banknotes in 1913, it was designed to create some uniformity, and it was actually backed by a gold reserve. And you may or may not know that in 1971, that was no longer backed by a gold reserve, and that caused this cascade throughout the world of disassociating a gold and silver-backed currency with what's more, what we term now, what's backed by what are the taxes that we're actually going to pay is what supposedly backs that banknote. And in 2008, we saw a very, very massive failure of the global financial system. It was a very large, systematic failure by institutions that were supposedly too big to fail. Failure is an opportunity. And so that's where Bitcoin, which seems like most of you have heard of by now, the genesis of Bitcoin came to be. It's time-stamped in the Genesis block, which is the very first block of Bitcoin, and there's a bit of hard-coded text in there, which is the same title of the Times on January 3rd, 2009, and it reads, "Chancellor on the brink of second bailout for banks." Bitcoin came into existence on the tail of the global financial crisis. And that's where we entered the age, the digital transformation of currencies, and the age of cryptocurrencies. What a cryptocurrency is, there's actually two parts, okay? It's very simple. It's a digital cash. There's something like a Bitcoin or Monero or Zcash or Ether, which is the actual cryptocurrency part. And then the underlying technology is what's called a blockchain. Now, a cryptocurrency is much more akin to that tally stick. Remember I talked about the history of money, those sticks at the very bottom in which marks what you have, maybe somewhere as a store. You can also contain a message. That's what a blockchain is, and a cryptocurrency is very much like a digital tally stick. And if you look at a cryptocurrency like Bitcoin, okay, so we set aside, like, what are the 6 characteristics that you define money? That would be good. Divisibility. Each Bitcoin is divisible by 10 to the 8th. 100 millionth is what a single Bitcoin can be divided into. The very base denomination is actually called a Satoshi. And Satoshi Nakamoto is actually the creator of Bitcoin. It's transportable. Right? It's a digital currency, so it's probably one of the most transportable currencies that you have. Scarcity. There's actually only 21 million Bitcoin that will ever get mined. So 21 million is the total number that will get issued, and it will happen approximately in the year 2140. fungible, okay? So you can exchange it. There are many merchant processors in which will exchange a good for that. But there are a little bit of areas of fungibility in one Bitcoin is not necessarily equivalent to another Bitcoin, not necessarily in value, but in the quality of the actual digital currency. It is durable, and it is most certainly non-consumable, even though I have been asked, why is it called a Bitcoin? And my daughter actually asked me once, why did somebody bite the coin? But it is not consumable. When you have very large institutions, so Jamie Dimon, CEO of JP Morgan, I've actually had a conversation with him, and he is on record at Davos and on YouTube saying Bitcoin is doomed. However, blockchain is for real. So let's talk about this for a second, because he's actually said to me, Bitcoin only needs to get big enough, and then the US government is going to shut it down. All right, so let's see what it would take to actually shut it down. Because there's not a single entity, there's no government, there's no institution that runs Bitcoin. Bitcoin is actually a peer-to-peer network that runs this cryptocurrency. And it's based on work that you have to prove. So let's say you're building this border wall, okay, the Trump wall. And everybody in the network is working on block 91 because all of the blocks before that, up to block 90, they're nice, they're secure, everybody agrees they've been cemented in place, and that section of the wall has been duplicated. And so everybody is working on block 91. But you decide, hey, I don't like this wall, I'm going to take it over, and so I want to actually alter the red block, which is block 74. What you have to do for cryptocurrency, like particular Bitcoin, is that you have to work on block 74 and all the blocks between 74 and 90 before 91 gets put into that little section there. And that involves some pretty hellacious computing power. How much computing power? This is how much computing power is in Bitcoin right now. It's 3,300 petahashes per second. That's petahash is 10 to the 15th. That's a frippin' lot of computing power, okay, to put it mildly. But let's say, all right, let's try to put this in context. What does that actually mean? So first of all, what's a hash? A hash is actually a mathematical problem, which is very difficult to solve, but it's very easy to make sure that you solved it correctly, okay? A hash rate is the amount of compute power, the amount that you're solving in a period of time. Okay, so right now it's at 3,300 petahashes per second. If you want to take over this network, you have to take over a majority of the network, okay? So 51%. 51% equates to approximately 1,700 petahashes per second. Okay, so what does that mean? That means that you better have a foundry at your disposal because you're going to need several hundred ASICs chips right now. So Taiwan Semiconductor, maybe a couple of the others, they need to be producing those chips right now. You need to either build or buy that mining equipment. Oh, and don't forget, you also need to have a power plant that can bring the equivalent of 2.6 billion kilowatt hours of electricity to the table right now. And it may not even be right now because WSO2 asked for my slides last week, so I looked up the hashing rate last week. It may be even more this week. And so that's what's involved in taking over the network. And the longer you wait, the lower the probability of being able to put that in place, because you have to put it and you have to grow it and grow it and grow it to maintain command of that network. So it's not that easy just to stop. And this I found on Reddit about 2 months ago. It was at the end of December. I thought this was pretty interesting because as defined by Narrow Money, which is M1 and M2, Bitcoin has a market cap which is larger than a number of the countries here on this planet. And that market cap right now is about $16 billion. But wait, there's not just Bitcoin. So when I talked about the age of cryptocurrency, the age of cryptocurrency is here. There is Bitcoin. Ethereum, which launched last summer, has a market cap of approximately $89 million right now. Ripple, not quite a blockchain, but nevertheless a digital currency. Litecoin, Monero, Dash, Ethereum Classic. These are only 7 of the cryptocurrencies that are out in the wild right now on open networks. So what's the difference? Okay, I started introducing Bitcoin. That's the first cryptocurrency. You can see now there are others. What's the difference between a cryptocurrency, a blockchain, Bitcoin? What is Bitcoin with a big B, Bitcoin with a little b? So now I wanted to start talking about what is a blockchain, and I'm going to try to explain that to you. So Bitcoin with a little b is not equivalent to blockchain and is not equivalent to Bitcoin with a big B. Bitcoin with a big B or Ethereum or a number of the other cryptocurrencies have what's called a protocol. And a protocol is a parameter, and it defines how the blockchain for that cryptocurrency operates. It defines what are the operations, what's the retargeting algorithm, what's the consensus. All of those parameters are defined in how that blockchain operates. Bitcoin with a small b, or Ether, or Dash, or Zcash, or Monero, the cryptocurrency parts, is the incentive. So what's very, very different about cryptocurrencies is they're all peer-to-peer networks. And in order to secure that peer-to-peer network, you provide an incentive. So in a digital cryptocurrency, digital cash, it is crypto economics is involved. The miners that validate all the transactions, I know this sounds completely foreign, I probably dropped in from Mars, but anyway, bear with me for a little bit. They actually get rewarded for finding that page, that block, by a certain number of cryptocurrencies. And it's because of that reward in which they continue to secure the network. And so what is a blockchain? Well, simply put, it's a block and it's a chain. But what it does is it actually solves things that were previously unsolvable. And those things are double spending, time stamping, and trust of execution in a massively distributed environment. Okay, so if I had a dollar bill, I could physically hand it to you. I don't know your name, I don't know your address, I don't know anything, I don't have your bank account, but I can hand that to you freely. However, if you walk out of that room, there's no way that you can retransmit that back to me. With a cryptocurrency, I can do that by only having your wallet address. You don't have to give me anything else, and I can send you the equivalent of $1. And what the network does, that peer-to-peer network of miners, validates that I have that dollar, actually. But more importantly, it's that double spend. I've only sent it to you and only you. The reason why you can't take a picture of a dollar bill or a check and send it as an attachment in an email to someone is because you can't prove that I actually haven't sent that same email with that same attachment to a million other people. With a blockchain, it's definitive proof that I've only done it once, and that's the double spend problem. And so you can see that fundamentally, the internet enabled this massive share of information. What blockchain, what cryptocurrencies do is enable the transfer of value. So a blockchain is composed of blocks. And the best analogy that I've heard is it's a ledger, okay? But because very few of us are actually accountants and we work in ledgers, we're like, what the hell is a ledger? Every single one of us knows what an Excel spreadsheet is, right? And every single one of us knows whatever your spreadsheet of choice is. A block is like a sheet on a spreadsheet, okay? It has a list of transactions in it, and the miners are incentivized to validate those transactions on that sheet and to append that next sheet to the spreadsheet before anybody else does. Because if they do that and everybody in the network agrees that that's a valid sheet, then the miners get that incentive, that reward, and that's where the cryptocurrency part of it comes in. In order to send a transaction, so each one of the line items in that sheet, that spreadsheet, has transactions. In order to do that, only have to have that private key. So it's a private public key pair in which I basically say I have ownership of that, whatever equivalent is. I unlock the transaction, I send it, and then I lock it again. You will hear that there are many types of blockchains. So IBM is making a lot of noise about Hyperledger Fabric. There's also C3 Corda. There's a lot of noise that's happening in regards to blockchains, and financial institutions are really, really adverse to any of the open networks. So if you were to roll back in the 1980s and say to a financial institution, there's this thing called the internet, in which, in the World Wide Web, you're going to send packets of information everywhere, globally. And what was the response back then is, no, we can't do that. We like internets. We're going to do internets. We're going to develop internets. And so when you look at something like blockchain, there's a lot of parallels there. A public blockchain like Bitcoin, like Ethereum, like Monero, Zcash, anybody can participate. The only thing that you have to bring is, if you want to participate in that peer-to-peer consensus model, you have to bring a certain amount of compute power, and your reward is commensurate with the amount of compute power that you bring to the table. But it is permissionless. It's completely open. It's completely decentralized. The other end of the spectrum, okay, actually, let me just step down, is a consortium. So we talked about the banks, all right? In a consortium blockchain, which is a permissioned blockchain, a group of institutions, a group of people say that we are the only ones that can participate. And we're going to set the rules that say, let's say there are 15 of us, that 10 of us must sign those blocks in order for those blocks to be valid. So that's the second example of a blockchain type. And the third example is a private blockchain. Now at BlockCypher, we run a couple private blockchains. I'm going to tell you right off the bat, they have very limited use. Perhaps maybe a government entity that issues land registry or Social Security, where it's only one person or one entity that's governing it, but you can leave read capabilities to others. There's limited use because the database works just fine for something like that, but it's great for testing if you're going to go into an open model and don't want to put real money on the table. What type of blockchain, whether it's a public, a consortium, or a private one, depends on whom do you trust. All right, so what's amazing to me for the open blockchains is you actually don't need to trust anybody. Okay, you can participate. You don't have to have anything other than your willingness to be part of that open network. They're the banks that do not think any of the open blockchains will work for them, and so they actually want to create a consortium because they think that they can trust other banks, and perhaps government agencies also think that you can trust other banks, but as was shown by the global financial crisis, maybe they're not as trustworthy as one would like to put our faith into. But, there's a lot of argument also that if all the miners, for example, in Bitcoin were to collude in China, then they would own 61% of the hashing power. So it depends who you want to trust. If I were a betting person, I would think that there's going to be a whole wide range of it, just like today. There is one internet, but there are many intranets. The same thing, we will have a handful of open cryptocurrency, open blockchain networks, but there will be many, many consortium blockchains. So now I'd like to describe a little bit about what we do at BlockCypher, how we fit into this whole digital transformation theme for WSO2. BlockCypher, as I said earlier, is like Amazon Web Services for blockchains. We're an API company, a web services company. These are our investors. So Sanjeeva is an investor. He was an angel investor of ours 3 years ago. He looked at me as if I dropped in from the moon, but thought, well, sounds like something that might be plausible. We have all 4 generations of Drapers, NEA Foundation Capital, Jerry Yang. So a nice list of investors. We also have the only 2 women investors in blockchain infrastructure, which I think is one of the coolest things. Where we fit into the blockchain stack, if you will, is at the infrastructure level, a little bit on the middleware level, right above the protocol. Right? So we implement various protocols. We're blockchain agnostic. And what we do, so if you look at any blockchain client, whether it's Bitcoin, whether it's Ethereum, whether any of those, they're all composed like so. Okay, these are all the same exact elements. Some of them will be different. There'll be different consensus, there'll be different sizes, retargeting algorithms, different scripting. For the most part, they were all designed as a desktop client. Why? Because it's meant to be decentralized. So your individual self can run it on a desktop, theoretically, although now Bitcoin you can't anymore. You used to be able to. But it's like running Excel as a database. Okay, so you can see that as we begin to scale. So the other thing I wanted to mention is it's pretty easy to get started. It's not so easy to run at scale. You also have to have a pretty fair understanding of many things. Okay, so not only peer-to-peer networks, but the cryptography, what is a simplified payment vehicle, how would you go about pruning a blockchain when it becomes, multiple terabytes, what are some of the chip designs that will be coming under consideration for the different mining algorithms, what sort of consensus, do you want proof of work, proof of stake, so all these things you have to understand. And it also makes it very difficult to hire expertise developers that understand blockchain, right? Because you do have to know the whole landscape. So where we come in is we just build APIs. So you don't have to actually worry about any of that crap. You can just say, all right, fine, we just want to use this API. We're off to the races and we're going to build our remittance application. So what we've done is broken apart all those little pieces that's in the client and made everything modular so we can scale everything independently. And yada yada. We also have multiple blockchains of data, and so we have a analytics framework so you can begin to extract information from our data stores and do really cool things of it. We have very traditional architecture, so we have an API layer, serves up our APIs via JSON over HTTP. At the bottom of the stack, we use a distributed database, Cassandra, in order to grow to whatever the size is for each of the blockchains and to hold all of that blockchain data. And all of our blockchain logic falls right in the middle. It contains all the cryptography, all the mechanisms in which to communicate with the different peers. To go from a reference client that's designed on your desktop to actually running in the cloud, blockchain as a service actually takes quite a bit of work. And so the road to production, to actually run, enterprise-grade applications, you do have to run a blockchain as a service, and it takes quite a bit amount of time to do that. And so that's the value proposition that BlockCypher brings to the table, is that we are cloud optimized, we're blockchain agnostic. We've been running for multiple years now with 5 nines and no single point of failure, yada, yada. And so our benefits are you can get to market much faster. In 1 hour, you can create a wallet and get going on your blockchain application and can continue to save lots of cost on an ongoing basis, because it actually takes quite a bit to run blockchain infrastructure. This is a analyst that put out, where we fit. We're a general API, but we have customers in each one of those categories, including our little general API category. These are our customers. We have customers on just about every single continent except Antarctica. They go from Latin America to Japan to the Nordics, and the use cases. So this is the part that I get really excited about as an API company, is because we get to see the ATMs, the payment processors, the stamperies, the indie artists that want to put like a little hash of their piece of art onto the blockchain. So you see that entire spectrum of what people are tinkering with blockchain technology as an API company. But not only that, not only startups tinkering, very large institutions like the federal government, the U.S. federal government, Department of Homeland Security has issued quite a number of RFPs now to explore how blockchain can be used across their various entities within DHS. Financial crime. So what's interesting is that in a transaction, in a cryptocurrency transaction, other than the ones that are designed to be fully anonymous, Bitcoin is actually pseudo-anonymous, which means you can actually follow the path of money a lot easier than you can with the US dollar. And so Homeland Security and law enforcement is looking at how do you catch the bad guys by doing analytics and following that path. Payment cards, credit card companies are looking, of course, they're all looking at the consortium-based blockchains, are seeing how they might be able to improve running a credit card on a blockchain rather than in their typical database structure. Identity management. Okay, so when you think about timestamping, trust of execution, that single source of proof that something is of existence, identity, as we know, right, it's just a matter of time that our identities are actually going to be stolen. There are a lot of companies that are looking at utilizing blockchains in order to prove identity. Okay, so how can you marry biometric along with, government-issued identification and put a hash on a blockchain, and which one depends on what form of identity wants to get stored there, in order to prove that you are the owner of that identity. Peer-to-peer payments. So when you transfer anything across border, it's going to take you between 10% and 35% that you're going to lose in doing that cross-border payment. So there are companies that are actually looking at using things such as Bitcoin as the underlying technology so that you, as a user, don't care what's sending it over, but instead of waiting 3 weeks and paying umpty squat amount in charges in order to process that transaction, by using a cryptocurrency as the rails and converting on both sides to fiat, it's actually a much more elegant way to do peer-to-peer payments. And I'm not sure if this video is going to come through, but when you talk about IoT, so that was one of the themes also for this conference in digital transformation. Okay. Can we, are you going to go to the actual video? Okay. So this was actually tweeted out to me. It's a little Arduino device in somebody who's sending, so you have a phone and Arduino device there. He's sending a small fractions of cryptocurrency over to the Arduino device. And when the Arduino device registers the payment, it will light up green. And so you can see that in the age of machine-to-machine in IoT, are machines going to send credit card payments to one another? Probably not. It's going to be much more akin to sending a cryptocurrency to another device because machines actually love the whole alphanumeric 23 to 31 numbers that define a cryptocurrency payment. And why developers around the world are tinkering with blockchain technology and cryptocurrencies is because for the first time now they have the capability to essentially become a central bank. So as a minter of a currency, I want to issue more currency. The only thing that I have to do is prove, who am I, and then I actually have this public key cryptography there, and I can issue it, and it's fully auditable. You can check on any blockchain, this is the amount that I've issued, this is what I've done, and that part is really cool, and this is one page of code. Now, I think governments might take exception to your becoming a central bank as a developer, as an individual, but you can see that institutions do have other forms of currency. If you look at any reward or loyalty point, right, they have to carry those as liabilities on their book. There is a value that's associated with it. And then there's all this reconciliation as to, well, is this Starwood point worth this for this airline mileage, which is equivalent to this hotel number? No, wait. We have to play with the books this year, so let's make this number of points, right? It changes very quickly, and it's also why you get these news articles like Dole, right? Dole had this. Did anybody see what happened to Dole and actually what the equity structure was? No. Okay. So what happened was Dole fell below a certain share price, and the CEO repurchased it, and then got a class action lawsuit that said you purchased it for too low, and so actually you have to pay all the stockholders a $2 differential to it. So when they actually started adding up all the stockholders, the numbers didn't add up. There were more shareholders than they thought that there was equity available. And why? Because there's all these different reconciliation systems and no single source of truth as to how many shares are actually available for Dole, and how many people needed to get paid that $2 differential. So in a blockchain, there is no argument on that, because when a transaction issues, it's settled simultaneously, and that's what the difference is. So that's how it becomes that single source of truth on a value. So where is this going to go? A study that was done on millennials has shown that 50% are counting on tech startups to disrupt the banking system, and that 71% would rather visit a dentist than go into a bank. So it gives you a little bit of indication as to where our world is going. It's going into a digital world. Not only is it going to transform in the cloud, governments are going to move to the cloud, financial institutions will also move to the cloud. It's funny because one of the number one asks I get from financial institutions is, do you offer your service on premise? Right? In which I want to say, yes, you want me to bring you a stack full of CDs also so that you can actually load it onto your servers. But you can see that everything is going digital, okay? And physical security has been around for a very, very long time. Digital security has not. And so there needs to be ways to guard private keys, to prove definitively that a digital asset is in existence and has been issued and has been transferred. And so the advent of cryptocurrencies parlays very nicely into the whole age of digital transformation. You will see all sorts of use cases, from property, land registry, assets, loyalty points, gaming, micropayments, and blockchains will be an intricate part of it. And I'm going to leave you with a little bit of magic. I'm sure for everybody in this room, there's probably no one except for one person that has heard of the Mimblewimble coin, right? There's a number of issues, and I touched upon one of them in regards to fungibility for Bitcoin. Scalability is another one. Bitcoin was the very first cryptocurrency. It will not be the last. And so you can say you heard it here first at WSO2Con. There is a protocol that is in development right now. It's still theoretical, largely, but it has a lot of potential to solve a number of the clunkiness issues that Bitcoin has. And it probably will come out this year. So watch out for Mimblewimble. It will have a governance problem, I'm sure, because all the developers, it's an open source project, but all the developers have pseudonyms that are Harry Potter characters. But we'll see where it goes. And so thank you very much for your time, especially right after lunch. I hope that not too many of you fell asleep. I can't see most of you. But the age of cryptocurrency is here. And if you have any more questions, please feel free to ping me. Thank you.